Okay, so everything that we've talked about geometric in nature, right? We've been looking at how to add, subtract vectors, how to represent vectors uh, in geometric form. We've really just been looking at pictures of vectors. Okay, I guess when we talk about vectors as arrows, we talked about the length of the arrow representing magnitude. Talked about the arrowhead and the way that the arrow is pointing, talking about the direction. Okay, but and we also talked about vectors being represented in words, right, with two numbers, where we have the magnitude given in a certain unit, given in certain units, and then the direction given usually as an angle, either in terms of bearing or in terms of true bearing or just regular bearing. Okay, so this talked about the direction. But now we're going to talk about a new way to represent vectors, and this might be a little bit easier in some ways to work with. Okay, and this way to represent vectors is called component form. Okay, a component form really is just taking a vector and breaking it up into two components. We're looking at it in terms of an x component and in terms of a y component. Okay, and so we're breaking it into two mini vectors, one vector that is always horizontal, one vector that is always vertical. And this is in reference to our xy coordinate plane. Okay, and so the horizontal vector is my x step, or my x component, and my vertical vector is my y step, or my y component. And because these are vectors, okay, these are still vectors, they are they have direction. So if the horizontal vector is pointing to the right, we say that it is positive. It's going in the positive direction. So we read it just like we would when we're finding a point on the coordinate system. You know, if I go this way, I'm going in the positive direction. If I'm going this way, I'm going in the negative direction. And the same thing goes for the y component. If I go up on my y-axis, okay, then I'm going in the positive y direction, and so my vector, that value, that number becomes positive, and if I'm going down, it becomes negative. All right. So let's do a couple examples here. This vector is the vector b. It's going 3 units to the right and 5 units up. Okay. So the x component, the x vector, would go this way, and that would be 3 units, and this vector, the y component, would be going up 5 units. So that's simply how we write the vector. This is the vector in component form. Okay, so we have these big parentheses and the x value on top, the y value on the bottom. So what would this one look like? If this was 1 unit, if this distance was 1, and let's say this distance was 2, what would be the direction of this vector? This would be going backwards, and since we said if it's going backwards it's minus, we say that's minus 1, and since it's still going up, it's going to be positive 2, so we would have minus 1 and 2. Okay, so this vector would be minus 1, 2. This vector we would say is 3, 5. So we read it just like a point. You might see in some other textbooks, you might see it written like this. Okay, but we're going to follow this notation. Okay, this is the notation that we will be using, and the DP will be using next year. All right. What about vectors between 2 points? Okay, vector. Now that we know how to write a vector using component form, this is really convenient for us now because we can actually quantify the vector between point A and point B. All right, so for instance here, the distance from I always look at the starting point as the tail of my vector and the end point as the tip of my vector, or the head of my vector. So this point, since the coordinates of this are a1, a2, that means this distance would be a1 and this distance would be a2. Okay, so in this case, the step, the x distance is just a1, and the y distance is just a2, so I could write this as a1, a2. Okay, so that's really nice. If I'm going from the origin to where O is the origin, if I'm going from the origin to a point, then all I need to do is look at the coordinates of that point and rewrite these numbers to look like this. Okay, so that's really convenient. Please do not write vectors as points, okay? Please do not do that. So never write OA, okay? Don't say this is A2, A1, A2, all right? This is wrong, okay? That would be a point. That looks like a point, okay? And we need to be talking about it as a vector, so please make sure it's a vertical column form, okay? All right, let's look at an example now where the starting point is not the origin. If I start at A1, or sorry, start at A and I need to go to B, then the vector here would be this distance, that the x component here would be this distance from here to here, and this distance would be the y step, right? So this would be the x step, this would be the y step. Well, what is this y step? From here to here, that's B2, right? From here to here, that would be A2. So this distance then would be B2 minus A2, right? And from this point, I guess from this point to this point, that distance would be B1 minus A1. Okay, so that makes things very convenient. All right, we can say that a vector between 2 points, where the vector is going from A to B, is really just the coordinates of my B minus the coordinates of my A. Okay, of the A point. So the x value here would be B1 minus A1, and then on the bottom the y coordinate would be B2 minus A2. Okay, so that is a very convenient way of finding the vector between 2 points. Okay, so I take the coordinates, I guess you could say take coordinates of B, of n point, and then subtract coordinates of, sorry, this is messy, of the starting point. Okay? Starting point from the coordinates of the endpoint. That's really how we find the vector between 2 points. Okay? And as far as reading this, we would say that B, this vector AB, is the position vector of B relative to A. It's saying, where is B relative to my starting point A? Okay, so the position vector of B relative to point A. And we talked about this description before. Okay, let's do a couple examples. Given the points A is 2, -3, and B is 4, 2, what is AB and what is BA? Well, BAB, remember we're going to take the points, the coordinates of B and subtract from them the coordinates of A. So this would be, since I have 4 and 2 here, I write it vertically, then I take away the coordinates of A. So I'm going to do -2 and minus a -3. Okay, that becomes 2, and that becomes 2 plus 3, so I end up with 5. Alright, so that there is the vector AB. Alright, so that would be my answer there. For the vector BA, this time, I'm going to go from point B to A, so I need to go backwards when I'm finding the vector. I'm going to take my points 2, -3 and subtract from them 4 and 2. And so I end up with -2 and -5. Okay, so notice here, what do you notice about the components? Okay, A to B is +2, +5, B to A is -2, -5. So these are actually opposite, okay, of each other, or they're going in opposite directions. Okay, and that makes sense, right? If I had point A and point B, okay, and I would go this way, well, the opposite of that would just be that, okay? And so you can see here there's a connection with what we learned before. This makes things nice because now we can actually quantify vectors more easily and find vectors more quickly between 2 points without having to draw every time. Okay. All right, let's look at vector equality. Vector equality, we know vectors are equal if they have the same magnitude and if they have the same direction. Okay, well, it turns out that if two vectors have the same components, then they are also going to be equal to each other. Okay, so if I have this vector here and this vector here, and I measured the y step and the x step and the y step and this x step and this y step, and they both turned out to be the same, no matter where they are, they will be the same vector because they're going in the same direction, they form the same little triangle, and they have the same length. Okay? So this is a nice little rule to remember. If components are the same, then the vectors are equal. Okay? So let's try an example here. What would be the value of k if this vector is equal to this vector? All right? How would I solve this? Well, I could find the value of k. I know that the k value has to be a value where this will equal this and this will equal this. The components will be equal. So k squared equals 9. So k would be plus or minus 3. Okay, so it looks like I have two possible answers. Well, what about the bottom component? What about the y component? K must be negative 3 here, right? Sorry. That should be a minus 1. I'm sorry, I wrote that wrong. That should be a minus 1, okay? That doesn't work. Whoops. Okay, so that should be a minus 1. So if I have k minus 1 equals minus 4, then it works. Okay, now I have k equals minus 3, and so here I had two possible solutions, and here there's only one solution. So which k value will work? Well, it's obviously going to be the k equals minus 3. So k equals minus 3 would be the one that works for both the x component and the y component. Okay? All right, what about, let's try a word problem. What is a car travels at a speed of 20 meters per second in the direction of 125 degrees. Write this as a vector in component form. Okay, so I have a vector that's going to be pointing in the direction 125. Now, I didn't really mention this in the video, but we talked about it in class. This is a bearing. Okay, this is true bearing, and true bearing is measured from north. Okay, so it's measured from north, and it's rotated in a clockwise direction. Okay, so I'm going to go starting from north. I'm going to rotate to 125 degrees. So if I go I'm going past 90. It's 180 over here, so it's got to be somewhere over here. Okay, so this would be 125 degrees from true north. Okay, so that's my bearing. The length of this would be 20 meters per second, or 20 meters times second inverse. Okay, the reciprocal. And now they're saying, what is this vector in component form? So I need to find the components. I need to find the x component. I need to find the y component. Really, I'm just going to be looking for a triangle. I'm looking for this triangle right here. And I need to find x and y. Right? And of course these will have directions since these are also vectors. Okay? Now, if this is 125, that would be 125 minus 90, this angle, so that would be 35. Okay, and so now we can just use our trigonometry to figure out what x and y would be. So what would the x value be? Well, to find the x value, I'd have to do the cosine of 35. So cosine of 35 is equal to x over 20, and the sine of 35 would be equal to opposite over hypotenuse, so y over 20. Okay, and now I'd solve for this. I'd get x equals 20 times cosine of 35 degrees, y equals 20 times sine of 35 degrees. And if I do this on my calculator, I would get this x to be approximately 16.4, and y would be approximately 11.5. Okay, So the vector then would, if we write it in component form, the vector would be, okay, it would be 16. Now this is in the positive direction, right? And 11.5 is actually going to be in the negative direction because it's going down. So I need to be careful with my signs here and write a negative 11 here. So x would be 16.4 and y would be 11.5. All right.